Welcome back to you watching this video. So we are still on module number 3, but we are already on the last unit. So this is unit 11. So influence chart for vertical pressure, or it is most famously known as the Newmark's chart. So this is the chart. So these circles are divided by several equally spaced radial lines. So these are your radial lines. So all of these are equally spaced. Okay. Next, the influence value of the chart is given by 1 over n, where n is equivalent to the number of elements in the chart. So you have here 1 over n, 1 over n, 1 over n, and so on. And there are 200 elements, hence the influence value is 0.005. Now, next, work for uniformly loaded area, any shape. So for any discussion that we had here in module 3 that are uniformly loaded area, then we can use Newmark's chart or the influence chart in solving for our delta sigma z. And the accuracy of the solution is based on the accuracy of perceived cell count. So mamaya mas magigets natin yan. Okay, so what are the procedure? Number 1, determine the depth of the depth z below the uniformly loaded area at which the stress increase is required. So we need to determine the z. And the plot of the loaded area with the scale z equal to the unit length of the chart. So for example, we have a depth z, then that would be that z is equivalent to from point A to point B of this chart, and this chart will be our basis. Okay. Number 3, plan the plot. Place the plan on the influence chart in such a way that the point below which stress is to be determined is located at the center of the chart. So if we are determining the delta sigma z at the edge, ilalagay natin yung edge dito sa center nung influence line natin. Okay? Then lastly, count the number of elements, m, of the chart enclosed by the plan of the loaded area. Then the increase in the pressure of the point under consideration is given by delta sigma z is equivalent to IV times Q times M, where IV is equivalent to the influence value and Q is the pressure on the loaded area. Then M is M is the number of elements. So, number of elements. Kung ilan yung pumasok dun sa diagram. Okay, so to understand that further, let's have here an example. So, it is good if you print this influence diagram on a, what do we call this, acetate. So, kung familiar kayo sa acetate, yun yung ginagamit natin before pa nauso yung projector. Yung merong ilaw tapos ipoproject sa screen. So, yung acetate is like a transparent sheet of paper. Okay, so yan. If you can print it there on this scale, or if hindi naman, then gawa kayo sa plastic cover, then scale nyo ito. So, dapat parehas yung size nito sa naka-print sa plastic cover nyo. Okay? So, pag gumagawa tayo ng diagram natin, ipapatong na lang natin ito. But it is better if you will be printing this on your acetate. So, IV here is equivalent to 0.05 because we have a 200 equal 200, what do we call that? We have 200 elements. Yan. Okay. So going back, we now have here an example. So this one was a problem sa earlier units natin. So refer to figures 3.73, a flexible circular area with a radius of 6. So ang radius natin here is 6. And our load is 450 kilopascals. Using the Newmark's chart, determine the increase in vertical stress delta sigma z at point A. So this is point A here. Okay? So Q 450, Z is 6. So importante na determine natin yung Z. Because here, yung Z na yan na yung magiging scale natin. Okay, so ibig sabihin, this distance here is 6 meters. Okay, so yan. So i-scale na natin, and it so happen here that the radius is 6 meters and nag-coincide siya sa Z. So from this point to this point is 6 meters. Tama? Ayan. So A to B is 6 meters. For this example, the scale of A to B is equivalent to Z is equivalent to 6. And for the circle area, R is equivalent to 6 meters. Z is equivalent to AB. Okay, so ito yung diagram natin, ito yung circle natin. At from this point to the center, nagkataon na 6 yung scale natin. Okay? So, etong kung saan natin hinahanap yung point, 'di ba? Delta sigma Z at point A, itatapat natin tong delta sigma Z at point A dito sa gitna. Ayan. So nakascale yan in such a way na itong 6 this is 6, ibig sabihin from this point to this point din ay 6. Okay? Okay, so pag na-draw mo na yung circle mo, etong acetate natin, itatapat natin itong gitna nitong new marks chart or itong influence chart natin dito sa A. So, I repeat, ang pinatong natin dito is yung acetate. Okay? So, we can now determine our M. So, count the number of elements of the chart enclosed by the plan of the loaded area. So, i-zoom natin. Ayan. So, if I am to zoom that, bibilangin natin yung na-enclose dito sa circle na to. Okay? So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, yung mga hindi sumakto, we are to estimate them. Kung ilang percentage yung nakapasok dito sa circle natin or sa ating area. Like for this example, we have 0.8, 0.46, 0.36, 0.6. 0.125, 0.7, 0.96. Here we have 0.01, 0.96. So we are to estimate them. And from that diagram, M therefore is equivalent to ayun, 66.42. Okay? So we need to take note that better to print the chart on acetate so that it can be used or placed directly on top of the diagram for easier counting of numbers of elements. Then count 1 for full circle element or cell element inside the area. So this is our area here. This is just a reminder that this is our area na buong itong cell na to nasa loob ng area. Therefore, we count that as 1. Now, consider ratio or proportion in decimal as represented for partial area element occupied by the area. Like for example here, the purple here, hindi naman buong itong cell na to na occupy. Therefore, we are going to have a ratio and proportion. And approximately, it is 0.125. Outside the biggest circle of the element approaches infinity. So itong side na to, this is approaching infinity. Therefore, maliit na yung value dyan. Okay? Then the accuracy of the answer is based on the assessment of numbers and elements with the loaded area. So I repeat, the accuracy is based on the assessment of number elements within the loaded area. So depende yan sa pag-assess mo. Okay? So using our equation, delta sigma Z is equivalent to IV. Our IV is 0.05. Our Q is 450 times our M, our assessment, is 66.42. Therefore, delta sigma Z at point A, yan, at this point, 3 meters below, is equivalent to 149.455 kilopascals. Okay, so another example here is the rectangle one. So, ito yung isa sa mga examples natin. Refer to figure 3.3, 3.78. A flexible rectangular area is subjected to a uniformly distributed load of 225 kilopascals. Using Newmark's chart, determine the increased in vertical stress at depth equivalent to Z. Okay, so for the procedure, una nating i-determine si Z. Since Z is equivalent to 3 meters, point A to point B therefore is equivalent to 3 meters. Okay? So this is line AB and this is 2 of line AB. Okay? So isasakto natin itong 3 meters na to dito sa line AB na yan. Okay? Then pag na-scale na natin, ang hinahanap natin is delta sigma Z at point A. Dito na natin ilalapat yung ating influence line, kung saan yung gitna nandito sa point A. Okay, so ito na yung kanyang itsura. Then, the next thing to do is to count kung ilan yung nakapasok sa ating area. So, ilang M. So, we have 40.12. Okay, then after that, use our equation IV times Q times M, where IV is already given as 0.005 rather, and Q is 225, and our assessment of M is equivalent to 40.12, and that is equivalent to 45.135 kilopascals. Okay, so I repeat this, M is highly dependent on your assessment kung ilan yung area na nakapasok sa ating shape. Okay? If umabot ka na sa part na to, please do not share it with your classmates, because this is my way of assessing of how students are coping up with the videos I am posting. Okay? And it is also on your advantage na din, because you will be able to solve the quiz. Okay? So this will be your quiz number 1 for finals. So solve and answer the following problems orderly and show complete solutions and indicate correct units. Use either the equation method or the table. Okay, I repeat, equation method or the table. Label properly and enclose your final answers in a rectangular box. Failure to follow instructions will invalidate your answers, and each excess answer will be a deduction of 5 points to the total score. So number 1, point load magnitude 150 and kilonewton at A and C respectively. Then determine the increase in vertical stress at a depth of 7 meters below the point B. Then number 2, an earth embankment is shown in the figure. Determine the stress increase at point A due to embankment load. And last, number 3, a rectangular area 3 meters by 1 meter is uniformly loaded with load intensity 100 kilopascal at the ground surface. Calculate the vertical pressure at a point 4 meter below one of its corners. Saan mo siya isasubmit? Send it to me via my messenger. So this is my messenger, and this would be the file name of your PDF. Okay, there's no need to add me, just send me your file name. Yung format ng paper, just follow yung format sa quiz natin. So you have there your name, class number, schedule, and so on. Okay, so yun lang naman. Good luck!